Gonna start talking about something brand new to you. This is like the first thing I feel like that we've done this year that you didn't at least have some experience with before. So today we are going to talk about polar coordinates. So far, everything that you have done in your mathematical life has been, and when somebody said graph something, you immediately did this, right? That's how we graph things. This is called a rectangular system. It's called a rectangular system because points are identified. You do this like a piece of graph paper. Points are identified by a horizontal and a vertical, like a rectangle. So when you identify a point like that, what you're telling me is, okay, I went right 2, I went 2. That's a rectangular system. So what we're going to start talking about today is a circular system. So we're going to identify points. Handed these out a long time ago, guys. I'm sure everybody was supposed to come in and pick them up. So we're going to identify points not in terms of an x and a y, but for example, this point right here, let's say. We're going to identify him in terms of how far he is from the pole. In a rectangular system, that's called the origin. In a circular system, it's called the pole. So we're going to identify that point in terms of how far he is from the pole and what his angle in standard position is. Okay, so the way I've set this up, and different paper has different grids, just like you can rescale this, you can rescale these, but the way I have it set it up, this would be pi over 6, pi over 4, pi over 3. So if I want to identify that point right there in polar coordinates, r, comma, theta, not x, comma, y. These are x, comma, y, rectangular coordinates. Polar coordinates are r, comma, theta, where r is the distance from the pole. You can think of it as the radius, and theta is the angle in standard position. So that point would be 1 comma pi over 6. Okay, so let's look at example 1. Plot and label the following 4 coordinates on the grid above. Now, sometimes there's no labels at all. He provided your pi over 6, pi over 4, pi over 3 labels, but you understand those extend around the circle, right? Same thing as we had before. So 2 pi over 3, 3 pi over 4, you know, like that, all right? So go ahead and take a moment and see if you can plot those points while I take attendance. Today, isn't this her birthday? Did I hear that this morning? This is her birthday. 2 pi over 3. Be careful, he's got lots of circles there, so 2 pi over 3, did you put it like right there? And label it. Please get in the habit of labeling because that helps me grade. All right, 1 3 pi over 2, where'd you put that one? Right here? And 3 4 pi over 3. And, ooh, 2 negative pi over 6. So 2 negative pi over 6. Is that good? Do example 2. Same thing. Same thing. We may have to talk about one of them because it's a little tricky. Notice anything weird about this? Are these points all ending up in the same spot? Now I haven't done the last one because that was a little confusing to me. We might need to talk about that. But all those points got plotted in the same place. This is the first fundamental difference between the coordinate systems. In a rectangular system, if I said to you, what are the coordinates of that point right there? There's one answer. The answer is 1, 2, period. But in a polar system, if I say, what are the coordinates of that point? Well, the first thing you would probably say is 2, pi over 4. But could it also be these other things? There are infinitely many names for every point in the polar coordinate system. Because of that whole coterminal thing, you know? Okay, well, what about, my guess is that -2, 5 pi over 4, also ends up in the same place. That's my guess, is he's got all of these points plotted in the same place. Anybody want to try to interpret? This means a negative distance? Anybody know what that means? Any idea what that means? Well, you're kind of on the right track. You're actually reflecting it 180 degrees. So a negative radius means you're in the opposite quadrant. So if this were a positive number, I would come down here, right? That would be where I'd come, if that were a positive number, 5 pi over 4. But because it's negative, it reflects me across the origin. It flips me 180 degrees. So that point is actually plotted. That point is actually plotted the same place as these. A negative radius means 180 degree reflection. Okay? So if you were going to plot -3, pi over 6, where would it end up? It would not end up at pi over 6. It would end up at 7 pi over 6, pi, 180 degrees pi. So you can do negative angles, just rotate this way, and you can do negative r's by reflecting pi radians. Example 2. Plot the point with polar coordinates 3, 5 pi over 6. Okay, so I'm on example 3. Plot 3, 5 pi over 6. 3, 5 pi over 6 would be over here. Now in some different ways. So what are some other names for 3 comma 5 pi over 6? Can you think of any?
-3, 11 pi over 6.
-3, 11 pi over 6. Love it. Perfect. He made his radius negative. And what does that do to your angle? It moves it pi radians. So he added 6, 6 basically, right now.
3 -7 pi.
Love it. Looky there. What did she do? She said, okay, instead of going positive 5 pi over 6, I'm going to go the other way, right? So instead of going here, she's going to go here. Remember, a revolution is 2 pi. So if this is 5/6, then the other half of it, or the other piece of it, would have to be 7 pi over 6. Perfect. Are there any others, or is that it? I mean, that's 2. I know he asked for 2, but are there other? Oh, yeah, a few trillion, right? So what would be another one, Patrick?
3 -pi over 6.
3 negative pi over 6. Now be careful. Wouldn't that one be down here? And I need it to be up here. Oh, what if we did negative pi over 6? Would that work? Yeah. Yeah, that would work. Now, when you do your homework, you will see problems where I'm having you do this, but I will specify, and I will say things like r less than 0, theta bigger than 0. So that would be here, right? That would be this point. What's this one? R greater than 0, theta less than 0. And this one would be both of them less than 0. And the original point was both of them greater than 0. So I will tell you, I will specify here. So you'll have to find the point that matches whatever the directions are that I provided. Okay, well, as you can imagine, the fun in all this is moving back and forth, going from polar to rectangular and rectangular to polar. How does that work? Well, you guys, it is so easy, so easy. Let's look at our rectangular system. If I plot a point in my rectangular system and call it x comma y, would you agree that that would be a way to illustrate that? This angle right here, I'm going to call theta or something, I'll call it theta. And if I envision a circle containing that point, then this would be the radius. That picture has it all. It has x and y and r and theta and shows the relationship between them. What do I know? Look at this now. Think SOHCAHTOA. Think your definitions. What do you know about cosine theta? What does cosine theta equal? X over y. So what does x equal? R cosine theta? So every time you see an x, you can replace it with r cosine theta. Now wait, x is rectangular. If I need it to be polar, then I just rewrite it as r cosine theta. What about y? What does y equal? R cosine theta. Thank you. Right there you go. Now, would you agree, let's take another look at this picture. Would you agree that the tangent of theta is y over x? That's one of our definitions, right? Y over x. So theta will be the angle whose tangent is y over x. So if somebody gives me an x and a y, can I use my calculator to find the angle that represents? Sure. You've done that before. You do it all the time. Let's try one. Example 4. Convert the following points from polar to rectangular. You can certainly draw a picture of this if you wish, but you don't need to. You have been given an R and a theta. This is a polar coordinate pair. So you could plot it, it would be right over here, right? You want to make that or change that into X and Y. What do we know about X and Y? X equals our cosine theta, and Y equals our sine theta. It is that easy. Now, I don't even need a calculator for this one. What's the cosine of pi? -1. So 2 times -1, that's just going to be -2. What's the sine of pi? 2 times 0 is 0. So your rectangular coordinates for 2 comma pi are -2, 0. Does that make sense? If you think about this radius being 2 comma pi is right here. Isn't that also -2, 0? Yeah. All right. Try B. Exactly the same thing. You don't need a calculator. You can do B. What does X equal always? X equals our cosine. Y equals our sine. What's the cosine of 5 pi over 3? Cosine 5 pi over 3. 1/2. And what's the sine of 5 pi over 3? -√3/2. So my coordinates, my rectangular coordinates would be 2, -2√3. Does that make sense to everyone? All right, do C. Don't be worried. R is negative. Okay, fine, doesn't matter. It works the same way. You're going to do the same thing. R cosine, R sine. You don't have to change anything. What is the cosine of 7 pi over 6? Cosine 7 pi over 6. -√3/2. These signs are important, guys. You gotta remember our pluses and minuses. How about sine 7 pi over 6? -1/2. So it looks like we're gonna end up with 3√3/2, comma 3/2. Is that what you got? I want you to think about this for a second. This is X and Y. What quadrant is that in? First, okay, does that make sense in terms of the polar coordinates? The polar coordinates we had were -3, 7 pi over 6. Is that in quadrant 1? Yeah, because 7 pi over 6 is in 3, but it's a -r, so it flips it into 1. Perfect. All right, now we're going to go the other way. Now we're going to take a rectangular ordered pair, so we're starting with X and Y. We're gonna start with X and Y. And we're gonna change them into a polar ordered pair. So I plotted negative 2, 2. Does my picture make sense to you? Left, up. This is R, guys. How are you gonna find R? Pythagorean theorem, sure. So what's your R? Two root 2? Square root of 8? A squared plus B squared? Now, this is theta. All right, theta must be in standard position. You can tell, I hope, what this angle is. What angle is this? 45 degrees, we're in radians though, so we'll say pi over 4. Pi over 4, x and y match, pi over 4. Which makes theta what then? If this is pi over 4, theta is 3 pi over 4. So one possible ordered pair, remember polar pairs can be written lots of ways, but one possible way is 2 root 2, comma 3 pi over 4. Give me one with a negative r. This one's fine. This one is fine. But let's do some more. What would be the negative r? What would my angle be? 7 pi over 4. Good, 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 good. Good, good. Super. All right. Would you try B and C with your partner? See if you can figure out the polar coordinates for 1 comma negative 3 and 0 comma negative 5. You're finding the polar coordinates. This is asking you to think a little bit. We usually start wrapping this. That's our next class. Anybody got an answer you're willing to share for this first one? What did you get for polar coordinates for this first point? 2 5 pi over 3. Yes, that's exactly right. This is theta. This is theta. Does anybody have a question about that? Did everybody get that? Magnificent. Magnificent. Just for fun, what would it be with a negative r? 2 pi over 3. Very good. It changes by pi, remember? When you change the sign on r, your angle changes by pi, 180 degrees. All right, anybody get this one done? Here's our rectangular pair to straight down. What would be the coordinates here? Remember, you need an r and a theta. What do you think? What? 3 pi over 2 is my theta. What'd you put in there for r?
Oh, I don't know. I just started. Is it negative 5?
It's not negative 5, it's 5. Because isn't the point, Anna, right at, I mean, it's on 3 pi over 2, right? So if you want to make r negative, you can, but that's going to move that angle up to pi over 2. Yeah. Remember, r is the distance from the pole, so we are straight down 5, so r is 5. Here's your circle, r is 5. Got it? Okay, now we're going to do exactly the same thing, but we're going to do it with complex numbers. So far, everything we've done has been in terms of points. We just been dealing with points. Now we're going to deal with complex numbers. Anybody remember what a complex number is? Well, it's got an imaginary component to it. What do they look like? Can you give an example of one? 3 plus 2i. They're a plus bi. Or I prefer to think of it as x plus yi, because that's what the components are. X is the real part of the number, and y is the imaginary part of the number. Now, here's why we do this, you guys. Here's why we do it. Have you ever thought about taking the square root of something like 2 plus 3i? In order to do that, your number has to be in polar form, okay? If I want to do this problem, I have to change this into polar form. So that's what we're practicing today, is how do I make that change? Well, you already know, it's super simple. Example 6, the complex number has rectangular coordinates, -2, -2. So what he means is, that's your number. The x is -2 and the y is -2. And we're going to change that into polar form. That means instead of x, I'm going to have r cosine theta. And instead of y, I'm going to have r sine theta. There is your number in polar form. That's what it's going to look like. So what do you need to find? You need to find r and theta. Do we know how to do that? Yep, we just did it. This number looks like this. Left 2, down 2. What's his r? What'd you say? 2 root 2, yeah. Is that what you said? Sorry. 2 root 2. What's this reference angle right here? Both sides are 2's, so this angle's got to be pi over 4. But that is not theta. Theta is this, which would be 5 pi over 4. So we have 2 root 2 cosine 5 pi over 4 plus I, 2 root 2 sine 5 pi over 4. The I goes with the y, which means it'll go with the sine part of the problem. Okay, do we know the cosine of 5 pi over 4? Negative root 2 over 2. And likewise for the sine? What's going to happen when I multiply these together? These 2 are going to make a 2 that'll cancel with that. So what have I got? -2. These 2 are going to multiply and cancel with that. So what have I got? -2i. Wait a minute, what did I do? I just went around in a big circle because I'm right back to where I started. This is the answer to the question. That is your number in polar form. Polar form is r cosine theta plus I r sine theta. That is the polar form of the number. If you start evaluating, that brings you right back to your rectangular form. Wow, this is so incredibly easy. Okay, a complex number, number 7. A complex number is represented by a point in a complex plane. Using polar coordinates, it can be written this way. Alright, so here's my number. 4 cosine 7 pi over 6 plus I times 4 sine 7 pi over 6. Okay, so there's your polar form of your number. Write it using rectangular coordinates. Write it using rectangular coordinates. Okay, well that's what we just did right here. I think you can do this. What's the cosine of 7 pi over 6? Negative root 3 over 2. And what is the sine of 7 pi over 6? So what is my number in complex form or rectangular form? Negative 2 root 3 minus 2i. Look okay to everybody? Isn't this fun? It's cake, yeah. It's so fun. It's so easy. It's cake. All right, I forgot to put page numbers on these, but let's go to the next page where it says check your understanding. And let's check your understanding. Plot them on the grid they provided. And then rewrite them. Find 2 other polar coordinates for the same point. All right, so see if you can get them plotted first. You can talk to your partner. You work on it together. Do my plots match yours? Do you have them plotted like this? Yours looks better than mine because you have actual grid, but about where they are. Did you come up with another point, another way of writing, not another point, but another way of writing 3 comma pi over 3? What'd you come up with, a different way to write that? Negative 3 4 pi over 3, beautiful. Anybody come up with another one? 3 negative 5 pi over 3. What do you all think about that? How about 3 comma 7 pi over 3? Would that work? Because 7 pi over 3 is just an extra loop around there? Yeah, lots and lots of possibilities. Anybody want to discuss any of that? Now, this one, in order to plot it, I went ahead and rewrote it with a positive R in order to plot it. So I changed this by pi. So this would be another way of writing that. You may come up with another point, another way of writing that. 5 comma negative 5 pi over 4, is that one? Do they have another one? We discuss any of that? we're all just good? Okay, number 2. If the points r comma theta sub 1 and negative r comma theta sub 2 have the same location, what can you conclude about theta sub 1 and theta sub 2?
They're 180 degrees.
They're 180 degrees apart. They're pi radians apart, right? They're pi radians apart. Because if you change the sign on r, your angle gets reflected across the origin. So quadrant 1 to quadrant 3, quadrant 2 to quadrant 4. All right, do 3 and 4. Converting from polar to rectangular and rectangular to polar. So you can remember how to do that. Talk to each other. Remember, if it's polar, it's an r and a theta. You're changing it into an x and a y for problem 3. That's what we're doing for problem 3. And then for 4, we're starting with an x and a y, and we're changing it into an r and a theta. And if you ever get confused, just remember your little triangle that ties it all together. That's how you're gonna move. If you can't remember what you're doing. Okay, I need some questions. I got my answers up here. I did them kind of quick, so I don't know if they're right or not. What do you think? Anybody have a question about either one of those answers? Looks okay? No issues? Joe Funk, got any issues?
None at all.
None at all. I totally love it. All right, number 5. Which point is further from the origin? The point with rectangular coordinates -5, 3, or the point with polar coordinates 6, 5 pi over 6? Which one, if I plotted them both on the same grid, which one would be further from the origin? What?
The second one,
The second one. You're exactly right, Drew. Why?
the hypotenuse.
Exactly. He's the radius. He's thinking about the point -5, 3. This is how far he is from the origin, and that would be the square root of 34. How far is the polar point from the origin? 6. The radius is 6. So which is bigger, 6 or root 34? 6. Good work. All right, let's turn that page over and look at the next page where it says, why so complex? Because we know it really isn't complex. Consider the complex number 3 plus 2i. What is the real component of the number? 3. And the imaginary component is 2i. X is real, y is imaginary. We talked about that already. So horizontal is real, vertical is imaginary. So if you're going to graph a point that represents 3 plus 2i, what are going to be the coordinates of the point? 3, comma, just 3 comma 2 is where you put the point, right? Now, they've drawn a beautiful thing here that's got both rectangular and polar. So you can go ahead and plot that point. What are the coordinates of this complex number in polar coordinates? So we are graphing 3 comma 2. What would be the polar coordinates? Well, don't we need r? So r would be the square root of 13. And then we need theta. We're going to need a calculator because 2 and 3 are not special to me. So what do I press on my calculator? How do I find that angle? Second tangent 2 divided by 3. 0.588. Everybody okay with that? Everybody understand why that has to be a calculator problem? Alright. A complex number can be represented using the point 4 comma 5 pi over 6. Alright. Alright, plot that point 4 comma 5 pi over 6. Get on the circle with a radius of 4 and go around 5 pi over 6. What is the real component of the number? Okay, now we need to be really careful about this, guys. We need to be careful about this. X plus yi, this is real, this is imaginary. Now, what do you have with 4 comma 5 pi over 6? What do you have there? Is that an X and a Y? No, it's not. Can I get an X and a Y out of that? Okay, so X equals 4 cosine 5 pi over 6. There, whatever that is, that's your real component. Okay, and then your imaginary component will be 4 sine 5 pi over 6. Because when you write this number, and this is rectangular form, when you write it in polar form, it looks like this. So this is the real part, and this is the imaginary part. So what is our real part? Our real part is, what's the cosine of 5 pi over 6? Watch your signs. Did you say negative root 3 over 2? Okay. So negative 2 root 3. And this one will be 2. So your real component is negative 2 root 3, and your imaginary component is 2. Julia? Oh, yes, yes. Oh, wait, leave your review homework for our last quiz. I forgot to collect it. So would you leave that for me before you go? The rest of us, we're going to finish this problem. We're in number 5, because we just the answer B and C and D are done. B and C are done. Negative 2 plus 2i. And number 5. Just like the size or magnitude magnitude of a number is its absolute value, distance from zero. The magnitude of a complex number is its distance from the origin in the complex plane. What is the magnitude of 1 minus 4i? Read the question again. I kind of went through it kind of fast. Read it again. The magnitude is its distance from the origin. So what is the magnitude, and that's the way we denote it, what is the magnitude of that number? Don't make it hard. It's cake, as Xander would say.
One.
No,
Root 17.
Root 17. Root 17. Guys, if I plot this point, isn't it down here? How far is it from the origin? Isn't that how far it is from the origin? The magnitude of a complex number is R. Right? That's what it is. It's R. Okay, this is a vector. You guys in physics, complex numbers are represented as vectors, and the magnitude of the vector just means its length, right? So that's what we did. Okay. All right, we'll stop there. We have a little bit more to go just in terms of review and recap, but you can probably start that homework since you got all these days to do it. You might